Now we're going to be working on number 4, and based on the information given in the scenario, we should conclude that we should use a paired t-test for this situation because it is a dependent scenario and you're looking at the same individuals on 2 separate occasions. So first we'll start by inputting our data, beginning with our exam 1 scores. Now the student column is really organizational, so you don't have to input that here in SPSS. So we're going to start with our exam 1 scores. And you want to make sure that you have exactly 14 participants. And then now we can go and input our exam 2 scores. And again, you want to make sure that you have 14 participants and double check all of your data to make sure that you input all the numbers in correctly. And now we're going to go over to our variable view and we're going to label our variables. And the first one for this case, so you just name them exam 1. And now SPSS, it doesn't accept spaces, so you can do like that, exam 1 without a space, or you can do an underscore, and our second measure is going to be exam 2. So, or you can do an underscore 2. So we don't need any decimals. We're just going to remove the 0.00 that was here previously, and we can go and change our measures to scale. Now, to perform our analysis, you go to Analyze, Compare Means, and Paired Samples t-test. Now here you're going to input both of your exam 1 and exam 2 over into the paired variable box and press OK. And in the first box, you're going to see your mean and standard deviations. And if you look at the end of the bottom box, you're going to see your p-value, which is 0.03. And because it's lower than our conventional alpha of 0.05, we will reject our null and conclude that there is a significant difference between exam 1 and exam 2. Now, to determine where that difference lies, you can go back up to your mean, and we see that the mean for exam 2 is higher than the mean for exam 1. So that tells us that the exam 2 scores were significantly higher than the exam 1 scores. Now, we're going to write up what we have concluded so far. We can say that based on our analysis, students score significantly higher on exam 2, and here you're going to want to input your mean and your standard deviation, which is 78.36, and your standard deviation which is 9.87. Then on exam 1, and you do the same thing of reporting their mean, which is 74.5, and the standard deviation of 12.79. So now, to get the rest of our statistical data that we need, we can go back down to our bottom box, and we're going to include our T and our degrees of freedom. So you can report your T, and then in parentheses you will include your degrees of freedom, which is 13. You'll find that right here in this bottom box. And then your t-value is here, which is negative 2.44. And you're going to include your p-value, which was 0.03, and your effect size, in this case is Cohen's d. And you can determine that by dividing your mean of differences divided by your standard deviation of differences. So if you do negative 3.857, which is found here, and you divide it by the standard deviation of differences, 5.908, you get 0.65. So that's going to be your effect size, and then you are complete with your write-up. Now to form the chart that expresses this data, you can go to Graphs, Chart Builder, and we can choose a line graph. And if you choose the simple one, and you drag it up to the top box, and then we're going to put both exam 1 and exam 2 on the y-axis, and we're going to input it up on the x. Then we're going to go over here to display error bars and the standard deviation, and we're going to change this to 1. And you apply that, and you press OK. And this is your line graph, and you can kind of see that the exam, it kind of increases from at exam 2, showing that exam 2 scores are higher than exam 1. And that is how you do problem 4.